Welcome everybody. My name is Joseph. I will be your moderator today on the final session of our QAZ Day 2020. This session will be about blockchain testing, which I think one of the most interesting topics during this conference. I would like to introduce to you in nutshells and then quickly our presenters today, because we have three ladies who will present this interesting topic to you: Alexandra, Anastasia, and Ina. And I would like to pass the words to you, you girls, because don't waste any time. Let's start. If you have any kind of questions regarding to the topic or the presentation, feel free to add your questions into the Q&A chat as usual. Enjoy.
Well, thank you, Joseph, for introduction. Well, I hope I'm audible. So let's start. Well, three of us and here are going to present or to introduce to you the blockchain testing topic. And well, let's start with a little bit deeper introduction. I'm Alexandra Pitkevich, and I'm leading the blockchain practice at EPAM. And I'm looking to extending our blockchain footprint in terms of the technology, in terms of the business, with the new customers, methodologies, and everything. And we have two nice ladies, Irina Pashnyuk and Anastasia Halkina, who are professional software test engineers and also very active members of blockchain testing community at EPAM. And they will help me today. Basically, three of us will introduce the blockchain testing topic for you. Please be aware that it's an introduction. The topic itself much wider and much deeper, but we would like to place a good foundation for the future understanding and basically make the topic interesting for you. Let's continue. And first of all, let me explain why we are speaking about blockchain testing. Why actually the words testing and blockchain are coming together. What is so special in that? And I will start with the two stories. First of all, it's well known. It's like if you read about blockchain, you definitely heard the name DAO. And in 2016, DAO, Decentralized Autonomous Organization, which is effectively a venture capital fund for cryptocurrency and decentralized application domain, was attacked. The DAO actually was a complex smart contract on Ethereum network. To allow investors to leave the scheme, the DAO included something which called split function. It's basically enabled users to retrieve funds in Ethereum, which were initially invested in DAO. And basically, if investor wants to pull out their funds, they basically create a child DAO, approve their proposal to send ethers to the original investment, to the address, and after the period of 28 days, they will receive the funds. The hack came when the attacker exploited a vulnerability in a split function, just a function in a smart contract. And basically, when a split request was made before the transaction was registered, a recursive function simply transferred more ethers to the same DAO token. At the end, it cost about $50 million worth of ethers to the malicious or to the attacker. As a result, Ethereum network and Ethereum currency were split for two, ETC and ETH. And the reputation damage was also significant. And just try to think, stupid mistake in one function on the smart contract caused the damage which worth $50 million plus reputation damage. And well, if it would be like only case in the history, we probably can think like, okay, shit happens. But let's look at the Ethereum Bitcoin network. That was actually early. On 8th of August of 2010, one of the Bitcoin developers, that was Jeff Garzik, he actually was looking at the code and looking at the log of Bitcoin transactions, and occasionally noticed that one of the transactions were transferring many times more Bitcoins, which actually is supposed to exist. You know, Bitcoins have like the number, how many Bitcoins can exist in a network. And transaction was transferring much more of those numbers to like certain others. And yeah, after that, the guys looked and there was an attack which exploited the number overflow error in a code. And again, the damage was, well, actually, like if we would count, the damage was about 92 billions. But fortunately, the Bitcoin network was less democratic, and the guys just rolled back everything like it's never existed. But again, reputation damage cannot be underestimated. So you see, in both cases, just a software, just a code mistake caused the major financial and reputation damage. And that's why we are talking about the testing today, because blockchain technology is a technology where in many solutions, you're actually transferring the value, not the information about the value, but the real value. So if it would be attacked or transferred maliciously, you will lose this value and you will lose reputation. But let's start from the beginning. I do imagine that some people here do not know much about blockchain. So I will quickly introduce the blockchain topic for you. Then Anastasia will help me to speak about the methodology, and Irina will help me to speak about the meaning for the testing and also about the test tooling. So let's start. Blockchain overview. And basically, when we are speaking about blockchain solutions, we normally speak about distributed ledger, which is network where we have multiple nodes, where each node has a copy, and normally it's a full copy of the ledger. And those nodes in the network are able to process the transactions and are able to agree to the same decision over each transaction if it has happened, if it's valid, and about an order in which those transactions has happened. So basically, we are speaking about decentralized control, no single point of failure. Also, the transactions in this network are being chained to each other, like, you know, word blockchain, chain of blocks. Each new transaction, while being processed and while it's concluded, contains itself the digital signature of either previous transaction, either the previous sequence of the transactions. So every time we're adding new transactions, we're actually signing upon the previous state, which means that all transactions in a network are coming chained to each other. And that creates another major quality of this network, immutability. That means that we can only add new transactions to the network. We cannot update something in the past. Well, for simplicity, you can think about that as the database with no update functionality. It's just you can only add. Also, as there's no single point for the decision making, there's a consensus mechanism which allows nodes to take a decision over the transaction processing and over sequencing. And well, there are many technologies implementing blockchain concept. There are many consensus mechanisms. The most important in consensus is there is an algorithm which lets nodes decide with no doubts if it's a valid transaction and in which order transactions has to be added to the chain. Also, as any database, blockchain technology has possibility to program business logic. It's called on-chain code, or the popular term smart contracts. So similar to like ordinary databases, you do have possibility to add like stored procedures or triggers, which can affect the processing of the transactions and can do necessary calculations, can do necessary serialization, and well, everything you expect. And also, blockchain networks are very secure because all the communications is done encrypted, and all the nodes, all the smart contracts, all the parties initiating the transactions, and all the beneficiaries are identified by crypto pair. So to process anything, you need first to decrypt, and you need to decrypt with the correct keys. So let's briefly look what this new technology brings to the market. First of all, that brings trust. And the trust means we do have parties who are operating the nodes in a network who have a real access to the data. It's not more the different legal entities who have their own proprietary databases and integration in between, which is not bad, but it costs time. And it also introduces reconciliation topics, introduces all the errors because of the data migration, because of the errors in the code, because of the malicious manipulations or associated to the DBA access. No, it's not a different databases with the integration between. That's the same database with the online updates of the data across the whole network, stable and based on a consensus. Also, another major quality, auditability. Because of this chain of blocks and because of this impossibility to change something backwards, we're always sure about the state and which this ledger is or was before. It's not possible to hack it backwards because you will need to redo all the digital signatures over all the transactions, which is usually cost a lot of time, computer power, in some cases money. That's why when you need auditability, for example, when you need to present to regulating organizations, where you need to have the audit log for security purposes, the blockchain solutions are the best ones. Security. I've been speaking about encryption of everything and about the mechanisms to identify and authentify based on a crypto pair. Automation. Smart contracts brings us the possibility to program business logic. It gives us the possibility to automate managerial decisions in the network, because a contract, well, smart contract is normally regarded as a digital copy of normal paper contract. And also availability and resilience. Decentralized technologies are much more resilient, much more available than centralized one. They don't have central point of failure. So when you understand that a little bit, let's speak about what is a smart contract a little bit more. So smart contract is a computer function which programs the business rules coded on blockchain. It has access to the transactions. It has an address in a network, and it itself saved as a transaction in a blockchain network. So it's also immutable. It's also versioned. If you need to update the smart contract code, you will need to deploy a new contract version, sending that as a transaction. You will need to have a consensus on that. And if your previous smart contract had balances on that, you will need to move all the balances to the new smart contract. And again, it's also distributed. The smart contracts are stored in every node of the network. So it's very resilient and very secure. Proceeding further, another main characteristic of supply chain network, which a lot of people do not really realize because they consider that the blockchain solutions are the cryptocurrency solution, is, well, we do have different types of the blockchain network. First of all, the first attribute is the access to the network. Who can access the network? And the networks can be public, where everybody can. And without any invitation or something, you simply install the software, install the wallet on your mobile, something on your server or something on your desktop applications, and you are able to operate. You simply start using the node code. Or the network can be private when you need registration in the network, which is done normally as a set of either legal or digital procedures or combination of those, where you need to be accepted as a part of the network. And a very good example of that are the consortium networks, where the participants of the consortia need to pass the onboarding procedure. So when we're speaking about the public networks, the majority of the cryptocurrencies are public networks. And when we're speaking about the enterprise solutions, they are normally private networks. And there is another attribute of the blockchain network, and that's called permissioning. The network can be permissioned and permissionless, and that's independently of how public or private it is. And when we are saying permissioned network, that means that we would like to define what participants are able to do in this network, what they're able to see, if the participants can see all the transactions or only transactions in which they participate. If the participants are able to run all the smart contracts or only those which belong to them or to belong to the certain subset of the participants. And the majority of enterprise solutions are private permission solutions. At the same time, for example, cryptocurrencies in the majority are permissionless, which means that every participant in the network can have access to every transaction in the network. They see the content of the transactions and they can see the code of the smart contracts. So with all this basic data, we are proceeding to how to test what this technology brings for the testing. And I will introduce Irina to start.
Yeah, thank you, Sasha. First of all, I would like to underline that blockchain brings huge challenges in testing world. Let's focus on the top key challenges. And the first point will be understanding the technology. Blockchain is a new technology and needs to be understood in depth before adopting blockchain as a technology. Technical expertise with a long domain knowledge is very important in testing blockchain application. The second point will be a lack of blockchain testing tools. Testing blockchain is all about tools. If you don't have the right set of tools, you're likely to fail. Testing blockchain applications requires a mixed tool set. Pick up the right tool as per the application is crucial decision. This point we will consider later. Next point will be lack of best practices. As you already know, blockchain is new technology and we face with lack of experience in developing blockchain application. This is one of the biggest challenges in the blockchain space. Blockchain technology was first introduced in 2008 by Satoshi Nakamoto in the form of Bitcoin. However, it has not been adopted in the industry due to a lack of experience and skills. This makes testing a challenging task. Regarding the test strategy, like any other applications, coming up with test strategy for blockchain technology requires a deep understanding of the application, its usage and the technology itself. Let's move on to the next point. This is addition of blocks. Please keep in mind when we add a new block in the chain, we have a new state for all our system. And if you found the defect, we don't have any opportunities to reproduce this case with the same preconditions. We cannot return the system to the initial or their state. We cannot update or delete the completed transaction. Blockchain technology is meant to be used to store and process huge amounts of data. It means that a lot of test cases to be considered. That will bring us to our next point, block and chain size. Testing the size of the block and chain is an important aspect for the blockchain application. This requires a proper validation of the data being added. Block size. A block contains a real-time ledger record with inscription and timestamp. There are groups of transactions which are confirmed and then shared on Bitcoin's public ledger, which is blockchain. In current time, testers focus on multiple questions such as what is the transaction size goes over the finite size. What test should be considered if there are multiple transactions in a block, and many more scenarios. Chain size. The chain size practically can be many blocks as the chain lengths. Testers should verify that chains are not broken at the time of testing. We need to verify that a complete record of transfer is tested under possible scenarios. Let's now talk about transmission of cryptographic data. The main crux of the blockchain technology is the transmission of encrypted data. There is high risk of failure. Testing around data loss during transmission is carried out. The peer-to-peer architecture of blockchain deals with data encryption at source and decryption at the receiving end. Testing for transmission ensures minimum data loss, improved process workflows between peers. Sasha, let's switch to integration testing. The world ecosystem was originally a biological term used to describe a group of organisms interacting with one another. When we talk about blockchain ecosystem, there are the groups of actors interacting with one another within the world of blockchain. In our typical blockchain, actors include users, miners, developers, and more. The core interaction between these actors take place in the form of transactions, but these transactions are limited to the blockchain itself. To ensure that ecosystem fulfill their purpose, they are often controlled. Include the creation of application, integration with external system, and more. Hence, integration testing must be carried out frequently to avoid any failures. To care responsibility is to ensure that the response from all interfaces is consistent and there are no disconnects. Security testing, next point. Security testing is another aspect of testing blockchain application. As mentioned earlier, securing the data should be the high priority. Blockchain technology can be used in various sectors like health, banking, finance, education, and any kind of security breach would lead to a huge loss. As a company, you need to understand that blockchain is also not completely secure and take steps to make it safe. There is representing the list of more popular the type of security risk, such as human-related risk, a risk with private and public key. The whole idea of blockchain or distributed ledger technology relies heavily on the public and private keys. These keys are a series of characters that offers unique security properties. One security property is that it's tough to guess. Blockchain work with this key. If you don't have the right combination of the public or private key, you cannot access the digital content stored with the blockchain. Vendor risk and untested code. Many ad hoc platforms and services work with distributed ledger technology to improve its functionality. We still see growth. It's evident that we will also see growth in third-party development. This includes solutions such as wallets, payment process, smart contracts, blockchain payment platforms, and so on. The quality of the code remains a big concern to most of the blockchain solutions. Decentralized organizations need to take extra care when they deploy their solutions. One of the primary blockchain security issues is the lack of regulation and standards. There are no mature standards addressing distributed ledger technology yet. The absence of international standards carries risk related to customer lock-in, lack of interoperability, privacy, and security. And the next point will be performance and load testing. Performance testing in blockchain is important because of number of transactions and transaction size being tested for the performance of block. The testing team focuses on other important independent parameters such as network latency, performance bottlenecks, the sequence of transactions at every node, and dependency of the production environment, transaction processing speed, and client user and system interface, along with the responses required from the smart contracts. To include, like any other application testing, blockchain application also requires the right set of skills and understanding to come up with the test strategy. Most importantly, non-functional testing becomes a key challenge here. Sasha?
Well, basically, with all those challenges, I would like to emphasize that while existing testing solutions we have now, they are more suitable for centralized applications. The challenges we see, they're not that easy to overcome while using existing tools and using existing methodology. And back to the story I started this speech, you still remember how expensive is a failure. I can also refer to the parity bug, which cost, I think, 150 millions of the funds frozen in the network, again, because of the stupid software bug. And we started at EPAM to approach this topic because we needed to deliver solutions to our clients, and we need to be sure that our solutions are at a good quality. And we've looked at existing methodologies, and we understood that a lot of test types, a lot of the approaches are not covering the full set of the scope of the blockchain testing. And on top of that, blockchain governance. Basically, when we're speaking about decentralized network, we're normally speaking about the multiple parties involved, multiple legal entities involved, which means that we need to organize testing, acceptance, and quality standards in between different companies. And none of the methodologies before gave us this possibility, gave us this solid help of how to do so. And listening to Irina, again, the technical challenges were simply tools were not sufficient. With every transaction, your test environment is moving to the new state, and a rollback is tremendously expensive, which means that, yeah, you cannot have a chance to reproduce the bug. And you need a new set of the test tools. And the test tools started to appear in the market, but those tools were not really integrated, not really in line with the DevOps stack, not really in line with the development tools. So you do have bits and pieces here. Remember, well, I don't know how old our audience, but remember the times where C++ were main technology and Java just appeared. And while there simply were not enough tools to do the efficient testing, we are able to, but we need to know how, and we also need to do a lot of setup on top of that. So facing all those challenges at EPAM, we actually decided to create our own blockchain testing framework, which would be both combination of methodology and combination of tools. And also to cover another challenge on top of this, technology is young and new and not exactly mature, which means that in many cases, your solutioning, your architecture decision of usage of one or another technology can evolve over the time. You can start developing application in one technology stack and then face the need to migrate to another technology stack. Or you may need to integrate in between technology stacks. And for all of this, you need testing tools, a testing framework, which allows you the possibility to test in the different technology stacks and have the seamless integration in between. So today we're presenting the top of the iceberg of EPAM blockchain testing methodology, and Anastasia will guide you for the first and main part, methodology one. Nastya?
Thank you, Sasha. Yes. Well, is it really so hard and so many challenges around blockchain? Surprise, surprise! We already have traditional V model, and I'm sure that most of you can recognize this picture. So the basic testing principles are the same as for traditional software. We can just take this model and use it for blockchain projects. But testing of blockchain-based application has its peculiarities. First of all, we have a unit testing, and we are talking about blockchain. It should be smart contract unit validation, transaction time stamping testing. So what does it mean? It's a computer code expressing one or more business logic. And usually unit testing is a developer's responsibility. Move on, main tester's responsibility is a component integration testing. It can include testing of business rules through smart contract or usual test business environments. Requirements. And for example, it can be node consensus validation of tokenization, and depends on the project. QA team should cover the main business rules, anticipate most of risks. The main goal is prevent, pay attention, and analyze how system should works in the all unusual situations. We should predict all negative cases as early as possible, because as we know, the cost of failure may be too high. And the next one is sub-system integration test. Also, QA specialists have to check relationships between all parts of system. For example, shared ledger, database, events notifications, API, access control, payments. And talking about system integration testing, it's a good point to have a performance and security specialist on the project to test load testing, wallet signature testing, scalability and stability, and transaction processing. On the acceptance testing stage, we can test UI and mobile application interface, transaction verification, and sign-in. On the stage of testing, it's a good question. What environment we can provide for our customer to test blockchain system? We need to learn how to work with a production environment that is out of our control and poorly predictable. So the next slide, please. For any project, it's a good point to discuss responsible areas. For blockchain projects, it's also important to know which team should track a quality of product in each of testing stage and what environment can be provided for testing needs. And if we talk about open source project, we need to think about user expectations and user experience. Here, I think the skill needed is an ability to predict how the user will interact with the application, understanding of the UX concepts, and we describe roles and this responsibility on our master blockchain test plan. Moving on our next slide. Yes, well, let's discuss key points to focus your testing efforts on. Generally, it's functional testing, non-functional testing, Sasha, and testing specific to blockchain. Yes, let's move on to the next slide. Firstly, it's a functional testing. Generally, it's the basic testing on the components and system. Testing is undertaken with respect to use scenarios, main use cases, requirements, and specific business processes involved. Including integration testing, it tests the integration or interfaces between components and different parts of the system. With blockchain being deployed in various systems and environments, integration testing ensures consistency in performance critical to the flawless implementation of the blockchain. Secondly, it's a non-functional testing, which consists of security and performance testing. Security testing is essential to blockchain application debugging, as blockchain finds use in highly secure financial, government, and regulatory environments. How well does the system protect data and maintain the objective? Does it have the built-in capability to ward off malicious attacks? Testing for confidentiality, integrity, authentication, access, authorization, and critical components of security testing in blockchain applications. What about performance testing? So one of the most important criteria of blockchain application is speed. The performance and latency vary with the size of network and size of transactions. Performance testing is a critical stage of the testing lifecycle as it tests the speed of performance with a given workload and whether desired criteria are met. By defining the metrics for tuning the system and in defining performance bottlenecks, like database configuration, this process helps to determine whether the application is ready for production. And talking about peer node testing, move on to the next slide, please. A node is a device on the blockchain network with the ability to carry out multiple tasks, such as send, receive, create, or store data along distributed network routes. When multiple nodes interact with each other, they are termed as peers that work the same way. Nodes talk to the network and acquire more details about the network through their peers. Peer node testing is essential in maintaining the integrity of the network and shared ledgers. The power of blockchain applications lies in the shared ledger being precisely the same at each node with exactly the same set and sequence of transactions. It is achieved through consensus across all nodes in the order in which transactions are added to the network, validates the rigorous testing. Where nodes fail to fall concurrently or participate in the network within given time, performance testing helps to validate the consensus. Do the nodes in the network sync with other validating peers? Is the integrity of the network and shared ledger maintained throughout the testing? It's a good point to analyze relations between nodes if there is disbalancing, or do the nodes have a special settings? We as testers should think about it and keep in mind it. So, Ira, over to you.
Thank you, Nastya. As Sasha mentioned, that smart contract is a computer protocol that allows the performance of credible transactions without third parties. Smart contracts help you exchange money, property, shares, or anything of value in transparent, conflict-free way while avoiding the service of a middleman. At the core of the blockchain validation process is a smart contract. It refers to the set of software construct that automatically execute transaction when predefined conditions and business logic are met. Testing smart contracts involve simulation of all possible, expected and unexpected variables for every contract. In a given dynamic network, which vast numbers of nodes and probably combinations, automation of testing is significant. Maybe you have questions: why is contract testing so critical to blockchain? When a contract is created, it's perpetual. So, when a flaw is discovered, a fresh version of the contract is created and deployed. When you do so, data stored in the previous contract has to be manually initialized in sync with the past date. Another problem that comes up is that of updating a contract or rolling back an update. It plays a huge challenge for the quality assurance and debugging team. Sorry. The smart contracts testing process begins with validating the method, the inscription, and transmission. However, the most complex stage is validating the processing and execution of contracts. Sasha?
So let's speak about the blockchain specific, like a little bit more. First of all, when we are looking to a blockchain network, well, we've been speaking many times that it's a network which processes the transaction on a decentralized manner. And we need to make sure, and we need to have an evidence that every transaction will have the final state in this network. Basically, it won't be lost, won't be forgotten, and network will come to the single point of view of this transaction, if it's happened or not, and will be able to either add or not add to the chain. And that's actually the challenge. And at the same time, we will need to prove, test, and have an evidence that consensus mechanisms over the network, basically the decision making on this transaction processing and on this ordering of the transactions is done fairly. In many cases, consensus mechanism relies on their random assignment to the node to process the transaction. And it has to be random. It has to be random in reality, even over the network where the nodes do not always know each other, where the network characteristics between nodes are different, where the performance of each node is different. And we still need to ensure and prove and have evidence that consensus mechanism is fair. Because try to think about like what even simple disbalance where you have 5 nodes in a network, okay, permission solution, and one of the nodes has much faster network and much more performance. And due to our consensus mechanism or our infrastructure and the network setup, in 80% of the cases, this particular node has the rights to process the transactions, which means that attacking or manipulating with this node will make network to be vulnerable to decisions of this node. And in some cases, we need to prove that it's not possible, that the configuration of the solution we are suggesting to the customer, which is delivered to the customer, and the consensus mechanism is chosen or programmed, is resistant to that. There are many cases where the profiling of the client is important, where the format and the frequency of the transactions coming from the size of the network is not causing disbalance over the network. It's not appearing that some subnetwork or some set of the nodes are getting more privilege because of the configuration. And at the same time, we need to validate the messages itself. And as every messaging solution, it has many layers. And remember still, it can be also with permissions, which means that we need to test the permissioning. We need to test the areas of the visibility of the data, and we need to test the permissions by each of the participants, again, in a decentralized network. And at the same time, we are facing the challenge, I've been mentioning it before, governance challenge. Blockchain network is a solution which is brought live or developed by the set of the stakeholders, and those stakeholders are normally different legal entities with the different architecture practices, different values, different requirements, different organizational structures, and different ways to make a decision. And with all this together, we need to bring a solution live. We need first to create a solution, then to test the solution, then to conclude that it's ready. Where, as I said, it's challenge even on the left side of the V model, where you have to come to the consistent set of the requirements and consistent priority of the requirements. And then you need to go through the development and align all the testing processes. And I would say, yeah, everybody knows how complex that on a sizable project with one set of the stakeholders. Try to think how to multiply that. And also these relations between organizations can be programmed on top of the blockchain network. We can have smart contracts programming SLAs and offering fees over processing certain operations. And that's called on-chain governance. And these governance aspects needs to be tested too. And when they're on-chain, it needs to be tested as a part of the code and needs to be concluded that it's working. But when it's off-chain governance, means the same relations are not coded as a part of the your technical solutions, a part of the network. No, they are recorded as a legal documents, which also needs to be tested. Onboarding of the new organization and ecosystem, offboarding of the ecosystem, disputes in ecosystem, disaster recovery, all these governance topics needs to be tested. And also the decision over the new functionality of bringing new versions live, they need to be well defined and accepted. And acceptance is normally done on the basis of the testing. And then even the platform brings us challenges and brings us necessity to test. Remember, we were saying that everything is identified by the key pair, and the keys needs to be stored and needs to be managed and needs to be rotated according the rules of the organization participating. And introducing a network of multiple organizations, we're introducing the multiplication of integration need, because still there's like none of the solution can exist in a vacuum, which means that in every node we do have integration requirements, and they're not always the same, and we always need to find, compromise, the middle line, and to have API which is sufficient for all those nodes to get the information or to send the information into the solution. And deployment requirements and the development infrastructure, operational infrastructure, all of this needs to be designed, implemented, and surprise tested. And we need to confirm this. And all those test types, they're new to the solution. Normally, you do not test the possibility to do the development. Normally, you do not test the possibility to upgrade your solution. You have a party responsible, you're just paying for that. And here, when you have multiple organizations involved, it's not only time and responsibility, it's also money question. Who does what, and on what permissions, what requirements, and what SLAs are behind that. And here we are coming to, remember, I was speaking about that we decided to create a framework. And currently you heard about the model, testing model, about the test types we're introducing, and now the qualities of the testing framework we actually have. We started to build that. We have certain version of that. We have the test automation supporting multiple platforms. But let's see the qualities. First of all, we definitely need test automation. Having multiple nodes, intricate infrastructure, we are not able to test everything manually. And we also would like to have a continuous integration, continuous testing, and we need to get the real-time test reports. having test automation always put the attempt to, first of all, use artificial intelligence to derive some test scenarios, and at the same time to use artificial intelligence to categorize the found bugs. Because, again, speaking about the multiple configurations, multiple nodes, multiple set of the requirements, multiple stakeholders, we are not always able to even coordinate tests manually. And that's why we are trying to have the connections to the AI, and starting from, bug classification, and then coming like being more eager also to derive test scripts automatically. And here we are coming to the need to have presets for industry. Basically, when we're speaking about the supply chain solutions in the blockchain space, that's pretty straightforward. The letter of credit, the bill of lading, those are the well-defined documents with the well-defined fields, which means that we can have the templates for the test cases specific to the industry. Again, there are a lot of industry regulations. There are a lot of industry protocols which are well known. The same in life science. The same for the government organizations. We can have the presets and deploy the presets to test the solution to be faster, to be more relevant for the industry. And obviously, well, definitely business, but later on, a lot of technical people would like to visualize the test processing and the test results. We all would like to have the nice, colorful dashboards which are saying how many tests were executed, how many had passed, how many defects of a certain severity and priority we have, and who is working on that now, and how quickly defects are resolved. And we would like to have that not somewhere in Excel sheets, somewhere in a complex industry solutions or log files. We would like to have the nice visual dashboards with all the charts and graphs ready to be consumed even by business. And speaking about the test excellence, we also we must look at our framework and our testing activities along the timeline. It's not necessarily one set of the testers working on that. So we need to make sure that the knowledge management is done well. And when we're speaking about the knowledge management, test data, a relation between test specialist and business analyst. Again, industry content is very important to store and manage. Then I was already speaking, DevOps, we need to deploy to multiple environments, in some case to multiple network configurations, the same code, multiple frameworks, multiple stacks of the blockchain solutions. And again, to have the deployment, to deploy the test framework, to have a predictable test runs, test execution, and test results. We also would like to build upon our experience, and not only to use framework, but to use like best practices of using the same framework. Those are the meta knowledge. This is how to quickly roll it out, how the best way to have the master test plan, test strategy, testing documentation, enter and exit criteria, how to produce that seamlessly, nicely, and not writing that from scratch every single time. And a collaboration across the team, to have all the communications, especially with the business analyst, because for blockchain solution, it's a key to understand what is happening. Because remember, we have smart contracts. The business practice, and in many cases, governance is coded in a network. We must understand that while testing. So, while designing all those approaches to the framework, we actually did a lot of practical work. And well, unfortunately, we are not able to do the demo today. We have limited time, and yeah, I have a sense that we are close to the end of our presentation. But we do have this framework now. We have master test plan. We have the model with all the test types defined. We have approaches for the test strategy, and for blocks you can build your test strategy. And most important, we have tools. We have test automation built for some of our open source or some of our internal projects, which is nearly to be able to reuse. And currently, I'm giving the word to Irina, who would be able to speak about the building blocks of our test automation, about the tooling which we were able to use.
Okay, now we come to the final phase of our presentation. This is the blockchain testing tools. As far as you can see, there is a massive variety of tools that you can see that you can use for testing. It depends on the application and the blockchain platforms. For example, Hyperledger Composer. This is an open source development tool and that contains many functions to help build blockchain applications. Also, this framework supports three types of testing: interactive testing, automated unit, and automated system testing. The next tool, for example, will be Corda testing tools. Corda is a distributed ledger platform that has a testing feature to help with writing contract and flow test, and also help with integration and load testing. Moving on to common tools used to test a smart contract with a brief description. I would like to consider the Embark framework. This is another popular, not previous.
It's
I
over
would
there.
Yeah, Embark. This is another popular framework for building, testing, and deployment your app. Focuses on development of decentralized applications that run on multiple nodes. Embark has integration with Ethereum blockchain and a couple of decentralized communication platforms such as Whisper and Orbit. And Truffle, this is platform supports testing features in place such as automated contract testing. Okay, now we can proceed with next slide, please. And we start from the Bitcoin testing tool. This is Bitcoin J. Bitcoin J is an excellent Java-based framework for Bitcoin-based application. It allows you to interact with the real BTC network and test transactions. So also you can simulate send and receive transaction in real time. Turn to Ethereum testing tools, namely to Ethereum Tester. Ethereum Tester is a pretty testing library that's available as a GitHub repo. Also, this framework is open source and the setup is easy. With Truffle framework, you already know, and at the end, Ganache testing tool. This is the most used library for testing Ethereum contracts, and you can develop your application and run test. I'm finished, Sasha.
Okay, and now back to me. Let's conclude what we've learned today. And basically, well, we would like you to understand that the blockchain solutions requires without testing. The cost of the mistake is tremendous. We would like, I hope you understood that standard testing approach is not covering all the aspects of the blockchain solution. We need to test, we need to have the new test types. And we need in some cases to have new metrics. And there are a lot of attention points which are on top of the standard testing. You obviously still need to test your solution on a functional basis. There's still traditional non-functional requirements, but something which brought for you from the blockchain technology is a smart contract attestation. And we always say that additionally to the traditional smart contract testing, you'd better apply for the formal attestation. That's a type of the services which is done in the world, and that's also shifts the legal liability of the solution creator towards the party who attested the smart contracts. There is always the emphasis on the security and the cryptography testing, and it consists on both program and infrastructure setup, consensus. And another thing which is very important, every time when the blockchain solutions were hacked, they were hacked through the negative flows. When everything works well, it's good, but all the hacks were like the intruders were using the vulnerabilities along the error and exception processing, where there was not complete, where there were holes in the error flows. And that's why we are saying it needs to be emphasis while testing the blockchain solutions of to make sure that you have the complete coverage on this. And at the same time, you have the technical parameters like the chain size, throughput, that's a performance parameter, and transaction finality. Those are really parameters of the blockchain solution. You will not meet them, a lot in the centralized technologies. And there are many tools at the market. Those tools can be used and they are maturing rapidly. The thing which needs to be done carefully is the selection of the tools according to your technology, according the development of your technology, according to your roadmap, and those tools need to be integrated properly. For current state of the maturity of the technology, you still need to do a lot of manual integration. Manual, I mean, you have to develop the integration between testing tools. You have to bring the pieces of the puzzle all together. And with that, we are close to closing our speech, but I would like to introduce that for EPAM testing competence, that we are planning the deep and hands-on demo over the automation testing for the blockchain solutions, I think on 20th of August. Joseph can correct me, but in August, we are coming to you with the 2 hours hands-on presentation explaining step by step what tools were used, how the configuration is, how the test scripts look like. And that would be the logical continuation on our introduction speech today. And currently, we are open for the questions. Joseph, will you help us?
Sure thing, I will help. Regarding to the upcoming test automation webinar, it will take place in the 28th of August, I believe, because we need to change this, but somewhere around it will, everybody will be announced this session, and it will be a practical demo. We have a couple of questions. Some of them were already answered during the presentation. For example, about the tools and the frameworks are available on the market, so I don't want to really read this question, but let's go to another one. Can you please elaborate blockchain testing by some real-time example used in your project that could help us understand end-to-end testing flow?
Where I'm trying to understand what is elaborating a real example. For example, we're delivering a cross-banking settlement solution where we are responsible for end-to-end testing. And we are not the only delivery partner. There are other partners who are delivering components of this solution. We are doing integration, like we're delivering integration, and we are testing everything, which means that we are agreeing with the client on a test strategy, on the maturity of the processes, and we are defining what needs to be tested, and we are estimating that. Where I can mention for you, like we have cross-partner integration tests in development environment to make sure that basically the transactions are coming through. And we do have like message serialization, which is good enough, and different components, because they're from a different technology stack, are able to read each other. Then we do have more like traditional functional testing. We have end-to-end product tests, which are showing us transactions from the beginning to the end. And at the same time, we are testing security parameters of the transactions and topology of the network and how the consensus is distributed over this network. And we are trying to visualize and monitor that. We also do have a lot of activities around adoption and around the governance, onboarding banks, all the fee calculations. We have a special test to test tokenomics, because while the tokens being transferred, there is a fee associated to the parties who are processing the transactions. Like it's similar to the miner fees, but all of this needs to be tested in the details. And yeah, that's the practical stuff. And if you're asking about the tools we are using, that's Ethereum stack. So Truffle, and not only like Gmeter, some traditional stuff, and yeah, and CI/CD pipeline. I mean, if somebody is interested in a practice, how it's done, first of all, come to our August session where we're demonstrating you another application, and we chose for demonstration the open source application with the code on GitHub, which will allow everybody to understand it well and to get access to the code and to everything. But at the same time, you know, boy, I will need another 2 hours to explain you how did we integrate and how did we install and the topology of the network, and especially because we do have distributed responsibilities over this. I hope that answer is enough, and I know that there might be the questions in the community that if you have particular technology question about how to do certain integration between certain tools, post it there, we will answer.
Thank you very much. Thank you for the answer. Unfortunately, we are really out of time at the moment, so we don't really have more time for other questions. I can suggest we can answer these questions in the next separated session because these have technology related stuff, and if somebody is not able to attend on that session, of course, we can answer it on the community Z, and you will find your answers on your questions. I would like to say thank you for your presentation. It was really good and interesting. And also, I would like to say a big thank you for everybody for joining our conference and our last presentation. I hope you enjoyed it, and see you next time. Thank you very much. Have a nice evening or day.
Thank you.
Thank you, and we will try to answer all the questions online and fast, so not wait for the next video session or something. Guys, post the questions, we're here, we're able to answer.
Thank you, Sasha. Bye-bye.